I'm going to do a problem here that requires use of an analysis of variance for the hypothesis testing. And you'll see here that they have, so all cars can be classified into one of four groups. So we're going to have, in a sense, four separate sets of data. A set for the subcompact vehicles, compact, mid-size, and full-size vehicles. Now, each group has 5 cars in it. And what we're testing is the head injury information for the dummies that were in the driver's seat. So we're going to see, is there a difference in the weight categories, and we're going to be comparing the means. So we're going to have 4 separate means, and we're going to start out by saying that they're the same. And we're going to test to see if there's any significant difference between any of the groups in the average weight between the injuries and the different types of cars. So we come over here and click on the icon, which will give us the data set. Now, one thing that students do make mistakes on here is that they will put the data in as it appears, and we were doing that with the chi-square test, but the way this is listed, they have it listed across horizontally, and then we want to put it in vertically. So, for example, subcompact, these numbers will go in the first column, the compact, these will go in the second, the mid-size, the third, and so on. So what I'm going to do is open up Statdisk and show you how the first column here is the subcompact car data, and then the next column is the compact. So we're going up and down with that data instead of it being from left to right. And if you put it in that way, everything will work out okay. So once we take that data again, I'll show you, this is the data, and we put the column 1 with subcompact, column 2 compact, column 3 midsize, and then column 4 you put in the full-size data. So we're going to go to analysis, one-way analysis of variance, and then we have 4 columns of data. So here again we have 1, 2, 3, 4. We're going to use all this data here. So we click on 1, 2, 3, and 4 on the left. We'll test at a significance level of 5%, and just double check to see if that's what they want us to do in the problem. So you see here it says use a 5% significance level. So that's good. And then we just click evaluate. And we can see, if we want to even plot these results, you can see here's our test statistic, the blue line, and this is our critical value. So remember that when the test statistic is less than a critical value, then in this right-tailed test we will fail to reject the null hypothesis. If you look over here, our p-value is very large. So if we think in terms of the p-value and significance level, our p-value is much greater than the significance level of 5%, so we fail to reject. Now what we started out by saying was that the null hypothesis was that all groups were equal. All of the group means were equal. And we don't have evidence to really reject that, so we can't say that there was any significant differences between any of the group means. So we're going to accept our original hypothesis that the group means are basically the same, or that there's no real difference in the weight on the head injuries of the vehicles, and we can't really say then that for example, like a larger car would be safer than a smaller car.